Hello and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler and today we'll be doing unit number 4, lesson number 5 on bisecting an angle. As always with any type of constructions, you want to make sure that you have a straight edge, which typically is a ruler, although you won't use it to measure, just draw straight line segments, and you need your compass. Okay, so that's basically it, your straight edge and your compass. And today what we're going to do is we're going to be learning how to take an angle and cut it in half essentially. At the end of the lesson we'll also be looking at a little tiny geometric proof to re-emphasize something that we've kind of already learned about angle bisectors, but for now let's talk a little bit more about them. All right. One of the interesting things about angles is that a fundamental axiom of geometry, one of the most basic axioms, is that every angle has a bisector and it's a unique bisector. Okay? So there are not two lines that can bisect this angle. If I've got angle BAC as shown, right, then ray or line AD, let's say, is the only one that will bisect it. Okay? And in fact, let me move things around a little bit on this GeoGebra demonstration, all right, because we can actually see pretty easily, right, that as we move that thing around, there is only one bisector, which is kind of neat. And today, what we'll be looking at are the various steps that it takes to find this bisector. One thing that's kind of cool about it is that, of course, to bisect an angle, whatever is going to bisect it will go through the vertex. So what we have to do is we have to kind of locate this second point, point D if you will, so that we can then draw that segment or that ray or that line. All right, let's jump right into it. It's actually a relatively easy construction. So let me walk you through it for the first time. Here we go. Exercise number 1, have those straight edges handy and your compasses. Letter A. Draw an arc with a center of A that intersects the two rays of the angle. Mark the intersection points B and C. All right, so let's do it. Let's bring our compass down, put the sharp end at A, open it up. How far should you open it up? Well, unlike drawing a perpendicular bisector, there's no, make sure that it's greater than half the distance, because these rays, remember, are going to extend forever. We just have to make sure now, as we draw an arc, that the arc passes through both of those rays. So here we go. All right, nice arc, passes through both rays. I'm going to move this away, and I'm going to label those intersection points as B, that's a beautiful looking B, and C. I don't even think that looks like a B. Anyway, so part of this question then says, what is true about both of these points with respect to A? What's true about both B and C with respect to A? Our favorite word, they are equidistant. They are equidistant from A. And of course they're equidistant from A because A is the center of a circle and B and C are 2 points on that circle. And so they must be the same distance away from A. All right, let's keep going. Part B, using B and C as centers, draw arcs of the same radius. This is key. Now that's not necessarily the same radius as here. You can keep the same radius, that's not a problem. But what I have to do is I have to draw an arc that's centered here and an arc that's centered here. And those two arcs have to have the same radius and they have to intersect. All right? So let's bring my compass over here. And in fact, even though the radius is still set the same as it was before, I'm going to make it a little bit smaller just to kind of really get into the fact that it doesn't have to be the same length. That slipped a little bit off of B. And it continues to slip off of B. Anyway, we'll do that. Now what I need to do, without changing that, I need to bring it up to C. Draw in that arc. Let's see, what does it say? We should label it point D, like that. Note that the arcs here don't need to be the same as the radius drawn in A. What is true about point D? Why don't you go ahead and answer that? All right, now be careful. D is equidistant from B and C. All right? So B and C are equidistant from A, and then D is equidistant from B and C. Whatever. No great surprise, this X marks the spot that we need. Final piece, draw a ray starting at A and passing through D. This ray now bisects angle A, and then we'll verify that using some tracing paper, or what I use as tracing paper. So I'm going to bring my ruler down, I'm going to put my 0 mark at A, rotate it around so that it passes through D, maybe do a little bit of this business, and there we go. Move my ruler out of the way. I claim now that ray AD, or line AD, bisects that angle. Now, you can verify this by taking a piece of tracing paper, putting it over one of the two smaller angles, and just verifying either with a reflection or something like that, that they are in fact congruent. What I did was I kind of knew how big the angle would be. So let me just do something really quick. I'm going to bring this hopefully out to the front. Order, bring to front. Right? So right there, that's half the angle. And then if I rotate it up, eventually rotate it up. That is also half the angle. For me, I'd have to take a little bit and continue to rotate it. But you can see, right, that what we've got here is we've got two angles that are now identical. Okay? So it's a pretty easy construction. Let me review the steps. I draw an initial arc to locate 2 points, B and C. You don't always have to label them B and C. You don't always have to label them, right? Those 2 points are equidistant from A. Then using points B and C, we then draw 2 additional arcs with the same radius, and where those arcs cross is point D, drawing a line segment or drawing a ray through A and D, the vertex of the original angle, and that point, right, we now have the angle bisector. Okay, let's take a look at why it bisects the angle. Okay, extend my page a little bit. Here is the proof. Here is the proof of that construction. Now, like some proofs, I have the statements filled in here and the reasons I'm asking you to fill in. So pause the video for a moment and see if you can fill in the reasons on this proof, and then we'll go through them. All right. Well, the first statement was that AB is congruent to AC. Now, why do we know that AB is congruent to AC in this construction? Well, it was by construction, right? I took my compass out and I drew that arc, right? So any points along those arcs are equidistant from that point. Great. Why is BD congruent to CD? Well, again, by construction, right? I took another arc and I centered it at B, and then without changing the radius, I centered it at C, so I knew that these two sides were equal. Finally, why is AD, this line segment, congruent to itself? Well, that's the reflexive property. Now think about that though, right? Now I've got a side equal to a side, a side equal to a side, and a side equal to a side. So why is triangle ABD congruent to triangle ACD? Well, that's due to the side-side-side theorem. Finally, I can now say that this angle is congruent to that angle because they're corresponding parts of congruent triangles, right? Corresponding parts of congruent triangles are congruent, and these two angles correspond to each other in these two congruent triangles. Finally, why can I now say that AD bisects BC? Well, that's really just the definition of an angle bisector, right? I mean, the plain fact is, if these two angles are equal, then this line segment, or that ray, must have bisected the angle. That's it. So it's really kind of cool, and again, it goes back to relying on constructing two congruent triangles, using some arcs, and then using that construction to locate two equal angles. All right, let's get some more practice with this. This is a fun construction. I like it a lot better than some of the other ones I've done simply because it's relatively easy. So let's take a look. Exercise number 2. Construct the angle bisector for each angle shown below. Leave all construction marks and verify that the angle has been bisected by using tracing paper. All right, so since we've only done it once, I'd like to walk you through this construction one more time right here, and then we'll have you do the next one on your own. So let's go through it. All right, so to construct this angle, I'm going to bring this up a little bit. I try to bring down something. Where do I put my ruler? I bring down my compass, put the center of my compass at the vertex of the angle, and draw a nice arc. All right. Step 1. If you don't want to change the radius of this arc when you draw the next two, that's fine. It's okay. I could bring this over here, use exactly the same radius. Well, actually, I think I'm going to need it to be a little bit bigger because I have to make sure that when I draw this arc, right, and then I put another one up here, that those two arcs intersect. That's the only kind of danger with using the same one, is that it may simply not have a big enough radius. Right, there's my other arc. Okay, the X now marks the spot. Bring this down. Let's draw a line through vertex C, through that. I'm going to put a little arrow on it just because I like it. And then I'm going to rotate my ruler needlessly, and I have my angle bisector. Again, it's nice to be able to verify this using tracing paper. For me, I already knew what half the angle looked like. So I bring it over here. That looks good. Maybe I rotate it. And I make sure that this angle is the same. There we go. And we've bisected the angle. Okay? Two congruent angles. Let's have you try it as well. All right, here I've got a nice right angle for you to bisect. Why don't you go through the procedure, maybe use some tracing paper to verify, and then we'll go through it together. All right, let's jump into it. Apparently though, I've forgotten some of my equipment, and this is one that I can't get away without. So I'm gonna, go back. Let me get out of this really quick, throw in a compass, and let's now go back into the full screen view. Okay, let's take a look at it. So let's take this, put it at the vertex, switch this around. Okay, draw myself an arc. Okay, bring this over to this intersection. And up. That's not going to be long enough. I can already tell that. Stretch it out. There we go. Yep, that's fine. Or at least I thought it was fine. There it is. Nice arc there. Bring it up to here. Lower. Yep, that's going to intersect. Another arc. Get rid of that. There we go. And bisected. All right. Now, of course, if we bisect a 90-degree angle, each angle should be 45 degrees. That's what I've got here, a nice 45-degree angle. And I see that it overlaps. I could rotate it to make sure that that was equivalent, but I know that's a 45-degree angle, and so I don't really need to check myself. For you, take tracing paper, trace that angle out, maybe reflect it across the angle bisector, and it should land right on top of that angle. Okay, an easy construction. That's the only construction we're going to do in today's lesson. But now let's take a look at one last piece, okay? Now, one of the facts of geometry, okay, and this is probably something that will make a lot of sense to you, like you kind of feel this, and we've talked about it before, is that the shortest distance from any point, like C, to any line, like line AB, okay, is the length of the perpendicular line segment that can be drawn from the point to the line, okay? So, it's weird because when we talk about the distance from a point to a line, all right, we don't tend to talk about the shortest distance or the direction of the distance or anything like that. But the plain fact is, right, if I had a line like this or something that I was trying to make look like a line, right, you could argue that this is the distance from the point to the line. You could argue that this is the distance that the point is from the line. But when we talk about the distance that a point is away from a line, what we're always talking about is the perpendicular distance because it's the shortest distance. And again, to illustrate that, let's take a look at this GeoGebra widget just a bit. In this particular screen, what I've got is I've got line AB and point C, and the distance between them is 5.01 units. I really tried to make it 5 units, I just couldn't get it there. Then what I've done is I've made point D lie on line AB, and notice its length is 7.21. And as I slide point D closer and closer to point E, notice how its length keeps getting shorter until ultimately it's that 5.01, and then it gets longer again. Again, all of this is to illustrate a very, very important idea. And that idea is that when we talk about the distance that a point is away from a line, we're always talking about the perpendicular distance that it is away from the line, which represents the shortest distance possible. Okay? That being said, let's look at the last problem. Okay, no construction here until the end, all right? So you can put those tools aside just for a moment. Let's take a look at exercise number 3. In the diagram below, angle CAB has been bisected by AD. So we know that AD bisects angle CAB. And D is just some arbitrary point on the bisector, okay? This is just some point on the bisector, such that CD and BD are perpendicular to AD, okay? Fair enough. Letter A. What triangle congruence theorem could be used to show that triangle ACD is congruent to triangle ABD? Explain your thinking. So given everything that we were told up here, which of the 5 triangle congruence theorems, side, 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 angle, side, angle, angle, side, or hypotenuse leg, could be used to justify that this triangle is congruent to that one? Pause the video now and think about what you know and which theorem would be the right one. All right, let's go through it. Well, what do we know? We know these 2 angles are right angles. We were told that. We know that AD bisects angle CAB. That's what's circled up there. That means angle 2 is congruent to angle 1. But that's really all that we were told. Still, we also know that the 2 triangles share the common side AD. So we've got an angle congruent to an angle congruent to an angle, and a side congruent to a side. And notice, the side congruent to a side does not lie between the 2 angles. So what I'm hoping is that you said it would be the angle-angle-side theorem. The reason why, angle 1 is congruent to angle 2. Angle ACD, that's this one, is congruent to angle BD, those are the 2 right angles, and then AD is congruent to itself, AD. So we've got an angle, and a side. Angle, angle, side. Not angle, side, angle. For that, the sides that had to be congruent would have been this one and this one, and we don't know that. Are they congruent? Yeah, they're congruent because the 2 triangles are congruent, so by CPCTC they're the same, but again, that's sort of reverse logic. We have to prove the triangles are congruent. All right, so whatever. So we know those 2 triangles are congruent. Letter B. What is true? What is true about CD and BD? What's true about CD and BD? Why must this be true? How does this show that D is equidistant from B and C? So what's true about CD and BD, etc., etc.? Pause the video now and write something down. All right, let's go through it. Well, CD must be congruent to BD. Why? Well, that's CP, CT, C, right? So these two things have to be the same length. Actually, maybe do 3 dashes, all right, because the two triangles are congruent, and because they're congruent, corresponding parts of the two triangles are congruent. Okay, how does this show that D is equidistant from B and C? Well, that's because CD is perpendicular to AC, and BD is perpendicular to AB, right? So the shortest distance from D to that ray and that ray, right, is that perpendicular distance. So the shortest distances are the same. Now, understand what this all gets at, okay? What this all gets at is something that we saw a few lessons ago, which is if a point lies on the angle bisector of an angle, then it must lie equidistant from the two rays of the angle. If a point lies on the angle bisector, then it must lie equidistant from the two rays of the angle. Okay? I think previously what we saw is that if a point lied equidistant from the two rays, it had to lie on the bisector. Now what we see is if it lies on the bisector, it must lie equidistant from the two rays. Okay? So to finish this off, letter C, construct a line that represents all points equidistant from the sides of angle BAD, not BAC, but BAD. So in other words, they could ask you to construct the angle bisector, but they could also ask you the same question or the same construction, but like this. So if they want us to construct all the points that are equidistant, right, equidistant from the sides of this angle, BAD, then we have to do the angle bisector of BAD. So why don't you go ahead and do that? I'll give you a few minutes while I'm going to write something up on the board, and then I'll go through it. All right, let me extend the page, and let's go through it. Let's bisect angle BAD, and that will give us all the points that are equidistant from one side of the angle as they are from the other. All right, we've done it a couple times so far. Let's do it one more time. Lengthen this out. Let's draw an arc, right? Then I'm going to come over here, maybe make this a little bit bigger. Come up here a bit, so I've got that part of it. Draw an arc like that. Bring this up here to the other point. Keep the arc the same radius. Get rid of this. It's supposed to go flying much faster. Let's bring this down here, our straight edge. X marks the spot. Uh-oh. There we go. And draw that line segment. Again, because this line bisects this angle, any point on it is equidistant from one side of the angle as it is from the other. All right, let's wrap this lesson up. So in this lesson, we saw a relatively easy construction, and that was the bisecting of an angle, and we'll need that quite a bit in our next lesson. So get lots of practice on it on the homework, okay? And besides that construction, we saw something that we've seen before, which is the equivalence of the angle bisector with all the points that lie equidistant from one side of an angle as they are from the other side of the angle. And again, I bet that makes a lot of sense to you, right? This idea that I've got these two rays of an angle, and if I take then a ray or a line that splits the angle right down the middle, then any point on that line segment will be equidistant from one side of the angle as it is from the other. All right. Anyhow, let me thank you for joining me for another Common Core geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.